Let's look at a two-tailed test now, which is definitely a little bit more difficult than the one-tailed test. Now, let's notice our alternate hypothesis has a not equal to symbol in it, which tells us it's a two-tailed test. And we have to be a little bit more careful with our two-tailed tests. So we're going to start with the same formula that we used in the last video to find our test statistic. We just have all this new information to deal with. So let's begin by plugging 63.4 in for mu. Our x bar is 60.1. Our sigma is 15.2, and our n is 62. So we'll go back here, and I still have that formula up top from the last video, so we're going to use it again. Z equals, our x bar in this instance was 60.1. Our mu was 63.4. Divided by sigma was 15.2, divided by the square root of 62. All right, so let's work out all of the top and all of the bottom. So starting with the top, 60.1 minus the 63.4 is negative 3.3. And now the bottom, that gives us 1.930402. And then finally, I'll divide those two numbers out. And I get negative 1.709, and I believe that we needed to round to 3 decimal places, so yes, so I'll just stop with that and not go further with my decimal places. All right, now we're going to look this up in Excel, but this is a two-tailed test. Just a couple of things here. If Z is positive, we're going to look up in Excel, subtract what we get from 1 and then multiply by 2. That will give us our p-value. Now, this case though, Z is negative. So if Z is negative, we look up in Excel and double what we get. All right, so in this case, we're going to look up negative 1.709. And whatever we get, we're going to double it. Now, this information is in that little handout that comes right before your exercises. So print that thing out, because that handout has a lot of helpful information that will help you through a problem. All right, now, let's go to Excel. Equal norm.dist. And we want to put negative 1.709 in true. And it gives me this, and I am going to copy and paste that back here. All right, so I said we want to double this for our p-value. So our p-value is going to be 2 times, and I'll just paste in what I had there, 2 times this. And let's see what that is when we put that in our calculator. And we're going to get 0.08745 as the p-value. Now we have to round p-values to 4 decimals, so 0.0875. Oh, 0.0875. And a while ago, that test statistic that I had, let me go back, should have gone in that first blank, which was negative 1.709. That would have gone here. All right, now our p-value is 0.0875. Our alpha is 0.005. Just comparing the first two numbers, 0.08 is bigger than 0.00. All right, so this p-value is bigger than alpha. So the p-value is greater than alpha. And recall, if a p-value is greater than alpha, we are going to fail to reject the null. Now be careful, we never accept the null. We're always trying to disprove the null, so we don't want to accept it. We just kind of want to say, well, we don't have enough evidence yet to embrace our alternate hypothesis. So we always say, fail to reject the null. which means there's not enough evidence for us to embrace our alternate hypothesis. And we want to look for sentences that say there's not enough evidence to embrace the mean being not equal to 63.4. So let's notice this one says there is sufficient evidence. That's not one of those we want. There is not sufficient evidence to warrant rejection of the claim that the mean is not equal. Well, we don't want rejection of the claim. We want to say there's not enough evidence to say that the mean is not equal to 63.4. So let's see. Again, this one doesn't have the not enough evidence kind of thing. So let's look at the last one. There is not sufficient sample evidence to support the alternate. And that's exactly what we're saying when we fail to reject the null. There's not enough evidence to support our alternate. So to support the claim that the population mean is not equal to 63.4. That's the one that we want. All right.